Okay, so we have here some yeast. Okay, we're not using that yeast. That's brown sugar. Sorry. Brown sugar, half a cube of butter, some cinnamon, a measuring cup with a fourth of a cup of water in it, quality filming job, an egg, sugar, the yeast that we are using, some flour. We have some more flour over there that we'll put in later. A pan that we're going to heat the milk and the butter, the other cube of butter, up in. Haley's pouring in the milk. Oh wait, we're not supposed to talk. Yeah, I'll just turn off the sound. Pour. We're not just supposed to
I don't know.
go over and film. Step up on it, go over. We're gonna add some yeast to the flour, some sugar, and yeah, half a cup of yeast, some water, an egg.
And just mix it. I'll put the water inside.
And the fourth cup of water.
Sure.
The definition of a leavening agent, like any recipe involving dough or bread, a leavening agent is required. A leavening agent is a substance you add when baking in order to make the dough rise. This is done by using something or doing something that creates gas by a chemical, physical, or biological means. In this case, we're using yeast or a leavening agent. Yeast is a biological leavening agent because it's a living single-celled fungus. There are 3 details that I have for you today. First, yeast is the driving force behind fermentation that works to leaven bread or dough by absorbing sugar and releasing CO2 and alcohol as byproducts. Once water, flour, and yeast blend, yeast and flour enzymes cause large starch molecules to break down into simple sugars that the yeast metabolizes. My second fact is, yeast does not only just allow dough in our cinnamon rolls to rise, but it also contributes to the taste of cinnamon rolls and other bread-related products. And third, the optimum temperature for yeast growth is 90 degrees Fahrenheit. Yeast cell death occurs above 100 degrees Fahrenheit. This is why it is important to mix yeast, water, and flour together with the water temperature at about room temperature. So as you can see, we are having a few issues.
We can't cook.
I'm just pouring this flour in.
Okay, go ahead. Now just make it dough.
We might need to add a little extra flour because we had a few errors. So we're going to improvise. Put it nicely.
Yeah, that's about how much you spilled out. Okay, now just try to make it dough with your hands.
I can't touch that. Oh, it's gross. Oh, it's like vomit. And stuff. The specific heat capacity of a substance is the amount of heat energy it takes to raise 1 gram of that substance by 1 degree Celsius. The higher the specific heat capacity, the more heat energy it takes to heat up and the longer it takes. The lower the specific heat capacity, the less heat energy is required to heat it up and the shorter it takes. For this recipe, we'll be using aluminum cookie sheets in order to cook our cinnamon rolls. Aluminum has a specific heat capacity of 0.9 joules per gram degree Celsius. 3 interesting details are, first, that it takes a long time to heat up water for a hot bath. The second, heat capacities of materials tend to mirror number of atoms or particles they contain. So the specific heat capacity of aluminum being 0.9 is a direct reflection of the number of atoms the element aluminum contains. Heat capacity is a physical property that scales with the size of a physical system. Therefore, a sample containing twice the amount of substance as another sample requires the transfer of twice the amount of heat to achieve the same change in temperature. Is it on?
Yeah.
So we started rolling out on accident. I forgot to film. We forgot to film, and we are rolling it out now. As you can see, our dough dried. We put it in this dish. I don't know if we're filming that either, but we did do that. Put a damp cloth over it. How much am I supposed to roll the dough out to?
Cinnamon mixture to the dough.
Our dough is quality.
Very. What is this?
See if I can get a cool camera shot. It looks like on the camera it looks like a giant.
Okay. And now we're just...
There are three ways in which heat energy is transferred. They are conduction, convection, and radiation. Conduction is the transfer of heat energy between particles in a solid. Convection is the transfer of energy by the motion of a heated liquid or gas. Radiation is the transfer of heat energy through empty space. Three interesting facts that I have are,
This is our final
like,
product of our cinnamon
an
roll.
example of radiation is like a heater, like a radiant heater that we see all over school, or not see, that we have all over school. Another example, or fun fact, about the heat transfer, such as convection, is that it is a very dangerous form of heat transfer that causes many wildfires. Another fun fact about conduction is that it also causes wildfires and it's a danger, but not nearly as great as convection.